Hey folks, Mr. Bullock here, and this pre-calculus lesson, it's also an Algebra 2 lesson I teach also, is on permutations and combinations. So let's go ahead and begin. It's kind of a long lesson, so I'm going to go fast, you guys. Let M sub 1, M sub 2, M sub 3 represent 3 math courses, S sub 1, S sub 2 represent 2 science courses, and H1, H2 represent 3 humanities courses. Paul will choose one class from each of his for his schedule, for his next schedule. Make a tree diagram to show all possibilities. Okay, so what I'm going to do here is he can do, this is one math class. Remember, he has 3 math classes. So of the one math class, he can have, one science class or this science class, the science class 1 or science class 2, and he can go math class 1, science class 1, humanities 1, humanities 2, or math class 1, science 2, humanities 1, humanities 2. So it gives me these 4 different outcomes right here. Okay, so there's 4 different outcomes. Like this one says math 1, science 1, or science 2, humanities 1, and so on. So there's 4 of them. Okay, well, I can do it for math 2 and math 3 over there, so it gives me these 12 different outcomes of possible choices that Paul can choose from right there. Does that make sense, you guys? So for example, he can do math 3, science 1, humanities 2. Okay, that would be this guy right here. Okay, all right, so there's 12 different outcomes right there, so 12 different ways. Let me get this out of the way here. All right, so the choices of selection of a math class does not affect the choice of the ways of selecting a science class or even a humanities class. So these choices are called independent events. All right, events that do affect each other are called dependent events. So for example, here's some example of dependent events. Say you're running a race and the order in which the runners come in first, second, and third. Your third place runner totally depends on who came in second, who totally depends on who came in first. Okay, so it depends on order. So we're pulling 2 cards from a deck. Say you're pulling 2 cards one at a time, and you pull one out and you do not replace it. Okay, so the second card totally depends on which card you pulled out and left out. Okay, so without replacement. So this branch of mathematics is called Combinatorics, I think it's called. I call it basic counting principles. Same thing, combinations and permutations is what this is about. So basic counting principles. So suppose one event can be chosen in P different ways and another independent event can be chosen in Q ways. Then the 2 events can be chosen successively in P times Q different number of ways right here. Okay, and we're going to use this later on towards the end of the lesson. When more than one things are happening, you multiply those. So an example for Paul, he had 3 math classes, he had 2 science classes, he had 2 humanities classes, so the number of different ways was 3 times 2 times 2. Okay, and we're looking for how many different ways there are, basically, you guys, okay? So here we go. Vicky has been asked to arrange a set of 5 bestseller books for a display. The display is to be set up as shown below. So the display is made up of 1 book from each of 5 categories, and they are, there's 4 nonfiction books, 4 science fiction, 3 history, 3 romance, and 3 mystery books. For what? There's no math books? How dare they? For each to choose from. Okay, so she's got to put them all here. So are these choices independent or dependent? Okay, well, since the choice of one type of book does not affect the choice of another type of book. These are independent events, okay? So how many different ways can she choose the books in this display? Okay, well, they're right up here. We're going to be multiplying. You know, there's 4 nonfiction, 4 science, 3 history, 3 romance, and 3 mysteries. So you just multiply all those numbers together and you get 432 different ways that she can arrange those right there. Okay, all right, let's try this. So when you're arranging objects in a certain order, it's called a permutation. Where order matters, it's called a permutation. So if you see the word arrangement, think permutation, you guys. So the symbol P parentheses n comma r says that it's the number of permutations of n objects that are taken r at a time. So the symbol PNN says the number of permutations of n objects taken all at once, and we have examples of both of those. So here's our formula for permutations, okay? So PNR is going to be the n factorial. I'll remind you what that is. You subtract n minus r and then factorial that, okay? And then PNN is just your n factorial right there. So remember, n factorial is whatever that number is times 1 less than that, 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 till you finally get down to 3 times 2 times 1. So for example, you guys, 5 factorial is 5 times 4 times 3 times 2 times 1, and that comes out to 120. Okay, when you run into 1 factorial or 0 factorial, those both equal 1. I'll show you why in a different video. It's just not enough time yet, especially the 0 factorial, but they both equal 1, okay? All right, so Mr. Clark has Mr. Clark has 4 books. Sorry, it's a bad writing right here. I got to change that. Has 4 books. He has an Algebra 1 book, a Geometry book, an Algebra 2 book, and a Precalculus book on his bookshelf. Okay, this should say has 4 books, comma. Okay, that's what it should say. Let's see if I can fix that for me right there. Probably take too much time. Okay, so how many different ways can he arrange these books? Okay, now order matters here, you guys, because once he puts a book on a shelf, the other books are dependent on which book went first. So for example, if he put the algebra book in the first spot, well, it can't be repeated because he only has 4 books, you guys. So he can put the Algebra 2, the Geometry, and the Precalculus, but that depends on what got put in the first spot and what got put in the second spot before I can place these 2 guys. So these guys are dependent, so this is a permutation when order matters, you guys. So if you ever see the word arrange or arrangement, think permutation, okay? So you're going to use your P formula. Here's one way. Make 4 blanks with multiple time symbols in between them, multiplication symbols in between them. So there's my 4 blanks, okay? How many books, how many choices does he have to put it in this first spot right here? Well, he has 4 books he can put in that spot right there. Okay, now that he's used that 1 book, he only has 3 more books to put in this spot right here. And then since he's used those 2 books, he only has 2 more books for this spot. And then finally 1 more book for that spot. So 4 times 3 times 2 times 1. So there's 24 different ways Mr. Clark can arrange his 4 textbooks. Okay, here's another way. Since there's 4 books and we're using all 4 of them, then this is and the word arrangement is in there, then this is just a P4 comma 4, okay, which is just 4 factorial, which is just 24. There's 24 different ways Mr. Clark can arrange the books on his bookshelf, okay? All right, so here's another one. The board of directors for the B&B Test Prep, which is an SAT prep company, consists of 10 members. How many different ways can all the members sit at the conference table, okay? And how many different ways can they elect a chairperson, vice chairperson, treasurer, secretary, assuming that one person can hold more than one office? Okay, for this one, how many different ways can the 10 members be seated? Okay, well, does order matter, you guys? Well, it does matter because once you sit one person, then it depends on who got sat there, and then there's you know, if there's 10 ways for this guy, then there's going to be 9 ways for this guy. There's going to be 8 ways for this guy, 7, 6, 5, 4, 3, or you can think of it as a permutation of choosing 10 and you're doing all 10 of them at once. Okay, so when you do 10 factorial, and you should have a factorial button in your calculator, you guys, 10 factorial is 3,628,800 different ways the board members can sit at the table. Wouldn't that be a fun exercise? Oh boy. Okay, and how many different ways can they elect a chairperson, vice chairperson, treasurer, secretary, assuming that one person cannot hold more than one office? Okay, you can do 4 blanks again if you want, and then there's 10 ways to do it on the first one, then there's 9 ways to do it on the second one, or there's 8, and then there's 7. Okay, and then because there's only 4 offices, so there's only 4 chairs. Or you can think of it as another permutation, and we're doing, we have 10 of people, and we're choosing 4 at a time. So permutation with 10, choose 4. Okay, so 10 factorial is 10 times 9 times 8 times 7 times 6, 5, 4, 3, 2, 1. Well, there's a 6, 5, 4, 3, 2, 1 on the bottom. but you can stop right there. Those cancel out, so we're just left with 10 times 9 times 8 times 7. Okay, and I get 5,040 different ways to elect. Okay, all right, when order does not matter, it becomes a combination. Okay, so combination formulas is almost like a permutation formula. In fact, here's the permutation formula. Oops, that doesn't need to be there. I can delete that out. Combination formula just has this extra r factorial, this number right here. Okay, so when order doesn't matter, we're going to use this formula. Now, most scientific calculators have these formulas programmed in there. I don't know how your calculator works. You'll have to figure that out, but it's pretty easy. I've tried them on several of them. It's pretty easy to solve, you guys. So let's try one. So find the number of combinations. Here they're telling me it's a combination, so I'm going to use this one. Find the number of combinations of the letters in the word solve, S-O-L-V-E. Okay, taking them first 5 at a time, and then second 2 at a time, and then list each combination. Okay, so here's the first one. Okay, we're doing, they told me it's a combination, so it's going to be 5 choosing 5. So 5 factorial over 5 factorial. This is 5 minus 5 factorial. Okay, remember that's just 1. These guys cancel out. That's just 1. And the only way you can do that is that. Remember, order doesn't matter, so I can do all 5 of those letters in any different order. It's the same group. Okay, it's like a group of people. They're going to go take a picture. It's going to be the same group of people no matter what order they're being put in right there. Okay, how about this one says you're doing 5 choosing 2. Okay, so it's going to be 5 factorial over this one factorial, and then 5 minus this one factorial. So 5 minus 2 is 3 factorial. Okay, and what I do is I just do this right here. I do 5 times 4 times, and I stop at the 3 factorial. Over, and then you got to write the smaller one out, 2 times 1. Okay, and then those cancel out, so I'm over 5 times 4 over 2 times 1 is 10. Okay, again, your calculators will get that for you, no problem. And there's all the 10 different ways right there. Okay, I started with the S's first, and when I extinguished the S's, then I started with the O's next. And when I extinguished the O's, okay, remember OS is the same as SO, so I didn't have to do OS. And then I did my L's and then finally my V right there. Okay. All right, so in a group of 10 people, each person shakes hands with everyone else at once. Sorry. How many handshakes are there? Okay, well, here's one way. I used to do this when I used to teach middle school, and I'd have 10 kids get up at the board. I'd first tell them, okay, shake hands, and they wouldn't. And then I'd say, how many handshakes were there? And nobody knew how many there were. And so we had to do a little ordering here. So what I did is I organized this, and I said, okay, this person, this number 1 goes through and shakes 1, 2, 3, 4, 5, 6, 7, 8, 9. He does 9 handshakes right there when he goes through. Okay? Now, he's done. He's shaked everybody's hand because he only shakes everybody's hand once. So he's done. So I'm going to cross him off the list. Okay? And then number 2 goes through and shakes hands. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so he goes through and so on. Okay, and then they keep going down, and then he's gone. So there ends up being, plus 7, plus 6, all the way down to plus 1, 45 handshakes. Okay, or you can figure out that this is a combination because order doesn't matter. 10 people choosing 2 at a time, and you get 45 handshakes that way. Okay, all right, so 7 points lie on a circle as shown in the figure. How many inscribed triangles can be constructed having 3 of these points as vertices? This is another combination formula, so I end up getting 35 triangles. All right, let's do one more. Standard deck of cards consists of 4 suits, clubs, diamonds, hearts, and spades, and 13 on each suit. So how many 5-card hands can be dealt that include 5 cards from the same suit? Okay, so 5 cards from one suit is combination 13 choosing 5, which I get 1287. But there's 4 suits, so I multiply that by 4, and I get 5,148. Okay, same deck of cards, except on our 5-card hand, we're going to have 4 of the same suit and 1 from a different suit. Okay, so this time there are 4 suits, each with 13 choosing 4, so I'm going to multiply 4 times the combination 13 choosing 4, and I get 2,860. And then we have the remaining 1 card has to come from the other 39 cards, because there's 13 cards out of the one suit, and so there's 39 cards out of a different suit. So that one's going to be 39 choosing 1, so I get 39 ways that way. Okay, when they both happen at once, I have to multiply those answers together since they're both happening together. So 111,540 total ways. And yes, sirree. Whoo! Take care, you guys.